Hello, my name is Tim, and welcome to this training video on compute clusters. What is a compute cluster? A compute cluster is the named resource that you will connect your notebook to that is actually going to represent the machines physically running your code. So to create a new cluster compute, we're going to go to the Compute tab on the left side here. We're going to go to the compute screen. You'll see that I already have two here, but we're going to create a brand new one. So at the top right, you will see a blue button. It might say something like this already, like create with something something policy. If you have access to more than one, you can click here and pick the one you want. If you don't have access to more than one, just pick the only one you have access to. So I'm going to choose this one, and I'm taken to the Create New Compute screen. So let's go through each of these one by one. You're going to give the compute a name. That's simple enough. I'm just going to call mine, demo cluster. And then you're going to choose a policy. The policy is responsible for dictating what kinds of compute resources you have access to. It'll also determine what permissions and things you have to change certain things. So I'm going to again choose this one. And now let's talk about performance. So the most important thing to pick here is the Databricks runtime. This is the specific version of Databricks suite of resources that your compute will actually attach to. You're going to have many choices here, so which one should you pick? You should pick the highest LTS version. So the one that you're seeing on the screen here is 16.4 LTS. LTS stands for long-term support. Generally best to pick the highest one. And then we see Scala either 2.13 or 2.12. I'm going to pick Scala 2.12. You might be wondering, why do I care about what version of Scala I'm using? I'm a Python programmer, or I'm an R programmer. Well, remember, we're actually Spark programmers, and R and Python are just the programming languages we use. Spark is actually written in Scala, so when you execute PySpark code or sparklyr code, Scala is running under the hood. So it's important to choose the right version of Scala. The reason I'm not choosing Scala 2.13 is because at the time of this recording, very many important things don't yet work on Scala 2.13. Notably, if you are an R user, Sparkly R is not yet compatible with Scala 2.13. That's at the time of the recording of this video. In the future, all such errors are hopefully going to be fixed, but you should be wary that if something doesn't work that should work, it could very well be your Scala version. So I will pick Scala 2.12 here. And then you can pick your worker type. So generally higher numbers are better, of course. I only have access to two here. You can downsize it, but I guess why would you if you're going to be doing something intense? So I can pick this one, works well enough. If you would like more compute resource than the options given to you, I would highly suggest checking out instead running Databricks jobs. Databricks jobs are not like clustered resources where you connect to a notebook and run them one by one. You build out code and have it run all at once. We allot higher resource allocation for this because generally they are running for less time and therefore a little bit more cost efficient, even though the clusters themselves might be more expensive. So again, if you want more than you're allowed to choose here, go ahead and use a Databricks job instead. Okay, I'm going to skip some of these optional arguments here, and I want to talk a little bit about the Advanced tab. So the Advanced tab has other things you could do, such as Spark environment variables and config settings. You can put an SSH key in here. There's logging things you can do. But the most important thing I want to talk about are init scripts. Advanced users might like to create init scripts. An init script is a script that will run as soon as a compute resource is spun up. So a good use case of this is if you want certain Python or R libraries pre-installed on your cluster before you begin coding, you might want to create an init script that installs them as soon as you boot up. Now, this might sound great, and for many of you, you absolutely want to use this, but there are two key disadvantages to creating init scripts here. The big one is this will increase the amount of time it takes for your cluster to be ready once you turn it on. Clusters already take kind of a long time to turn on, so this is a pretty big disadvantage. You're going to be waiting there for several minutes for your cluster to spin up. Another disadvantage is many users might try to run your notebook with their own cluster. So if your cluster installs a library and your colleague who uses their own cluster also, sorry, also tries to run that notebook, they might find that their code doesn't work because a library is not pre-installed like it was on your node. So it's just one more environment thing to be wary of. These are things that aren't the end of the world, but might steer you away from init scripts. Okay, well, that's enough. We are going to now create our resource. So I'm going to click create. And I think when you create a new resource, it automatically begins turning on. Yes, it is. So you see the spinning wheel here. It is already trying to start my cluster. Next, I want to show you how to actually connect your notebook to a cluster. So I'm going to click new up here, and I'm just going to create a new notebook. Just a fresh, empty one. And at the top right, you see connect. When I click down here, these are clusters I've already run in the past, but instead I'm going to create the new one. So when I click more, I'm going to search for the one I already access to. My demo cluster already shows up here because I created it recently, but you can also just type in here to search. So if I start typing demo, my demo cluster shows up. I'm going to click it and attach it. Okay, now you see up at the top right here, it is starting up. Clusters typically take several minutes to actually start up, so I'm not going to hang around and show you this, but once it is officially done, I can run code, for example, a 1+1. While it is spinning up, you'll get this waiting thing here, but if I were to wait a couple minutes, everything should run smoothly. Okay, thank you for watching. In this video, we learned how to create compute clusters with all of our preferred settings and how to create and how to attach that cluster to your notebook so that you can actually finally run your code. Thank you so much for watching. I will see you in the next one.